So although our knockback is working, when they get knocked back, it's just a consistent speed, which could be more interesting. So one way we can change that is by creating a curve resource and then sampling from that resource to figure out at what point during the knockback animation, we could say, that they should be going either faster or slower. So we could have a build-up of speed, or we could start really fast and then end kind of slow. So I think that this would be most appropriate in our weapon stats script, where we have our knockback stats. We'll just jump into knockback stats, and then we can add a curve here. So at export var curve, and this will be of type curve. I don't think it needs to be curve 2D here. So we'll start with a regular curve, and let's save this. Now if we open up weapon stats basic and we expand our knockback stats, then we should be able to see the curve resource here. So for the curve resource, let's do a new curve, we'll expand it, and you'll see this little blank graph. So let's start with a preset to make setting it up a little easier. If we click preset, we can do linear to start, which would pretty much give us the current value of, we just move at a consistent rate as we go from point 0 to point end. So on this graph, the duration is kind of our x value, and then the force is going to be our 0 to 1 in the y direction. So basically, as time progresses, the current velocity of our object is going to change. So let's click on the curve resource menu and choose a new curve. I'm going to go to presets and let's start with linear. So in this graph, x is basically going to be our time, the duration. So at 0.25 seconds, that's actually the 1 over here. And for 0 to 1, we are going to basically be taking the current force velocity and multiplying it by this value to find the final force. So with this graph, what would be occurring is that at the start of our movement, it wouldn't move at all, and at the end over here, it would move our full amount. So if we wanted it to work as it did right now, we could go to presets constant and then just move these up to 1, like so. And then we'd basically be doing 1.0 multiplied times the force for the entire duration. Rather than needing to do that for a simple knockback like we currently have, I'll just make it so that we only multiply it by the curve if one exists in our knockback stats. So if we wanted to have a buildup of speed, we could do linear here. So we start not moving and we end moving at the full rate. So we'd start not moving and we'd move at the full rate up here. So we can start with that and see if we want to adjust this. In the script, I'll give it a comment. So on this curve, x is the time elapsed of the duration, and then y is a multiplier for the force at the given time. So the y multiplier and the x time elapsed. And this should be optional. So when you set comments like this, you can hover over the property in the inspector, and you can read those comments there, by the way. So when you set comments like this in the script, you can read them in the inspector by hovering over them like this, by the way. So now we need to take this curve and apply it to the force when we create a hit. So in hit data, I think what we want to have here is just to sample the current force. I'll go with something like get velocity. So I might start with something like the base vector, which will be equal to the direction times the stats.force. So that'll be kind of like our base movement amount before we apply the curve. And then if stats.curve, then we're going to adjust that by whatever this sample value, let's say time elapsed, which is a float. Time elapsed, of course, will start at 0. And then we'll sample the curve and multiply its value by the base vector. So sample value equals stats.curve sample, and that'll sample the time elapsed. So before that, of course, we want to add time elapsed plus equals the p delta. And then when we have the sample value, which should be between 0 or 1 at a moment in time, adjusted by a curve if one exists in the knockback stats. So we're no longer going to use calculate force vector because we want our knockback velocity to be dynamically adjusted by the curve. And that means that our direction So we could actually just, let's say, rename this to adjust direction. And this will take the P hit direction vector 2. So instead of returning the calculated vector, which is the direction time, and then up here, we're going to adjust the direction. Call this the hit direction for the init. And then forget velocity. Okay, so one thing though, I think that this would work if we only have one object trying to get the velocity on a knockback per knockback, which usually would be the case. But if we have two objects at the same time passing in the delta, then the time elapsed is going to get kind of screwy. So I think a better solution might be to get float, and then this time start is going to be equal to time.get, let me go down here, ticks milliseconds, and I guess we want to times that by 1,000 to get it in seconds. Or hold on, no, divide by 1,000 to get seconds. Okay, and then we're going to basically take the time start in seconds and then use that to sample the curve. Okay, so this means we no longer need the p delta. We can just pass time start into this curve. Oh, not time start, but actually the current time minus the time start. So if our time elapsed would be, but I think to make this a little bit better, we can remove the divide by 1,000 here. So this will be in milliseconds. And then I'll cut this. So we calculate the difference in milliseconds first. And then, and like so. So then we're only dividing by 1,000 once. So this will just be milliseconds minus milliseconds, and then we convert it to seconds. So since I've removed a function from this knockback class, it's definitely going to break something in the game. So let's hit play, and we'll go to where we were. So since I changed a bunch of stuff in the knockback class, it's definitely going to cause some missing references inside of the game. So let's hit play and try to cause a knockback, and we'll see where we get issues. So the character velocity, instead of doing the force vector by the knockback multiplier, what we should be doing here is hit data.knockback.get velocity times the object stats knockback multiplier. Okay, so we can see nothing really changed, and that's because we're only checking the velocity before run. Also, the attack of the enemy, we never set a curve, so it is just working as before. So what we actually need to do is, while we're doing the play hit action, we need to calculate this on every tick. So on tick, if hit data.knockback exists, then we're going to set the velocity again, like so. Then we should look for the invaded collision stats and assign a curve to it. So I'll do a new curve, and let's do a preset linear. I'll hit play. Okay, and let's get hit by one of these guys. Okay, so nothing much seemed to happen there. Let's go into knockback, and I'm gonna set a keyframe here. And it looks like the direction was set to 0. So let's put a breakpoint there as well, so that when we get hit, we can see what direction we're getting hit from. Okay, and we can see if we look at the get move direction that we're taking the original direction out of the property, not the one passed in. So we want to copy and paste the name there, make sure we're using the p hit direction. That's one reason I've been naming the parameters with the p underscore, to make it very clear that we are using the parameter and not a property from our class. Okay, so let's hit play and see if that's working better now. Okay, so our adjusted direction is x1. That's what we would expect. Let's hit play. Also set a breakpoint there for the curve. So our curve's calculating. We have the time elapsed in seconds, 0.015. That looks correct. Our sample value is 0.015. That's what we would expect as well. Let me get rid of the breakpoint so that I can just kind of see it visually. Okay, so we can kind of see with the projectile. It is sort of working, because we can see it sort of accelerates over time. Is that when we're sampling the curve, it should be as a percentage of our total duration. So I should say var percentage elapsed, and this will be basically time elapsed seconds, let me see, divided by stats dot duration. Okay, I think that's right. So now that's what I want to be sampling. So let's shoot. Let me actually set a breakpoint and see if that's as intended. So if 0.016 seconds have elapsed, but we only need a quarter of a second for the movement to finish, then that should be 4 times the value here for the percentage elapsed. Okay, so that seems correct. And we hit play. Okay, and we can see that basically based on this, we would need to increase the base force by a lot, or we need to change the curve. So I'll search for stats, basic weapon stats. And you know what, maybe I'm just gonna change the invader collision stats to have the name weapon stats instead of just stats. That way I can search weapon and find it easier. But for our projectile, I think what I wanna do is have it start fast and end slow. But because it's gradually decreasing over time, I'm going to make the force 250 and then we'll hit play and we shoot. Okay, so now we can see the knockback is more like a sudden movement that slows down over time. So doesn't that feel a lot better than just having a consistent slide? This looks a lot more like an actual knockback. Okay, then we hit these guys over here too. And I could even shorten the duration, like 0.15, and then make the force 300 for an even more sudden jolt. Okay, so we hit these guys. Yep. Okay, and there's our tiny little knockback, right? Okay, so we want to do something similar with the invader hit. So on the invader, linear, we'll start fast and slow. You can even give it like Bezier curve handles if you do, like, let's say ease out. And we move this up here and this down below. Okay, so now we might want to click here, grab the curve handle and do something like this. So because it has like a bit of a slope, that should be able to smooth it out if you set it correctly. But our first will be, let's say 150 over 0.1 seconds. 0.15, let's go with. Okay, so if I hit play and we get hit, I can see it's not actually moving the character. So I'm thinking something else is actually setting the velocity of the character. So we need to figure out what's going on there. Yeah, so if we check the player in the physics process, we're already setting the velocity here. That's kind of problematic. So we were trying to move that to the states, right? So in the ground input, I think we set the velocity or just the direction. Okay, so let's check what the super function has on platformer character. Platformer character, apply gravity, and apply move and slide. But in the physics process, we're setting the velocity to be equal to the stats walk speed times the direction. Now, we should move this out of here. I'll save it, and that should actually go in ground input action. So I'm going to paste that in there, and we do player.velocity.x inside of our ground input action. So this state, or this section of the behavior tree, is controlling the player velocity. Okay, this is going to multiply by the player.stats.walkspeed. Or if we don't want to have to manually pull the stats out of the player, we could just say player.walk direction, player.walk. And then we can put this back in the player class, but we just don't call it on physics process automatically. So you could say function walk, which is going to do this line. So the velocity x is equal to the stats walk speed times the direction x, but we have to call this function separately. And on physics process, it's going to do the move and slide, but we're only going to call this from the outside script of the ground input. So only when we're calling this are we going to just have this movement override everything else. So if we hit play, and now I go into an enemy, yep, okay, there we can see now we are actually getting the knockback to occur properly because we're only able to do the walk movement when we are inside of that ground input. So that was basically just a remnant of the code from before we had the behave tree that we needed to work out and move into these states. So the walking only occurs when we're in this state, and in everything else, we don't have that option. So I can demonstrate that once again. We have our strong knockback from the enemy, perhaps even a little bit too strong or too fast. So I might increase the duration and I might lower the force. We're gonna play again, test that out. Okay, that's not too bad. So to give the player a little bit of extra invulnerability frames, what I might do is move the set hurtbox not invincible out of the hit sequence, but put it back into this bottom sequence down here for the ground input. I might rename this to be ground free movement. And then I could add another one of these splitters so that I could have this trigger after a timer. So if I right click here and add a behave node composite, a simple parallel composite, I think you can have two at once. So if I want to give our player a little bit more invincibility frames, then rather than setting the hurt box not invincible at the end of the hit sequence, I can do it at the start of the ground input sequence after a set period of time. So I think all I would need for that is another parallel composite. So if I right click up here and we add in a composite parallel, I'll move this one into here and we'll say this is the ground state, sure. And this can be just ground movement, I guess. Maybe I call them parallel composites still, so that it's a little bit more clear. Okay, and then right here, I'm gonna do set hurtbox not invincible. So I'll move that in there. But before this happens immediately, I wanna have a timer for it of sorts. So let's right click here, add a child node, and we want a time limiter decorator. No, that's not right. Decorator, and we want the delay decorator. Okay, so we put that in there, move this up a bit. The wait time is going to be however long we want the character to be invincible for after entering the ground state. So 0.1 second, let's say. And I'll move this under the delay decorator. Okay. So basically after a set delay, it can do the set hurtbox not invincible. Yep. And it's no longer part of the hit sequence. So I'm going to hit play and let's see if that works. Okay, so we got hit. Our character was invincible. And our character's invincible again. Okay, so now if we go into this bunch of dudes, it should be a little bit less abusive. I don't think 0.1 second was long enough. Let's make it a quarter second. Okay, so this actually took a little bit of testing to figure out. But what's going on with the delay decorator is that the before run will run immediately, even if there's a delay, but the tick has the wait time for a delay. So if I hit play here, you'll see that as soon as the game starts, the before run runs immediately. So that's why the delay wasn't doing anything. But if I hit play and continue, let's just remove that breakpoint, then you'll see that it takes a couple seconds for the tick to actually start. So if we want the set hurtbox invincible to work properly with these decorators, then I guess what we need to do is just take all of this, put it down into here, remove the before run, and then we'll return success. And then when we return success, this should stop operating, I would think. Well, let me see how many times that runs, and I'll remove this one temporarily. The other set invincible. Okay, so 2 seconds are gonna occur, and then we're gonna get the tick to run. We hit play. And yeah, it's done operating because it's already hit success. So this, I guess, should be all we need. One tick, and then we return success. So if I have things set up correctly now, then we take the delay decorator and set it to how much invincibility time we want after entering the ground state. Let's say 0.1 second. I'll hit play. And let's see if this works as intended. So we're going to be able to walk for a second. Yeah, it does seem to be there now. Let's make it 1 second to make it very obvious. So 1 second of invincibility after getting hit. Yeah, okay, there we go. That's working a lot better now. So I'll make this 0.25 seconds. All right, play. Then we can move our character, but we have like those invincibility frames. So it's a lot easier for us to escape the characters, the enemies, after getting hit. And this just feels a lot more fair as a player. So I'm not sure why the before tick works like that, but that seems to just be a feature of the Beehave tree. So something to be aware of, that the delay decorator only delays the tick function from operating, not the before enter from triggering. So you do have to be careful about that one. All right, so at this point, we've kind of improved the knockback. We have the curve. to give it a more of a smooth, nice animation with a strong upfront knockback and a weak tail end knockback. And we've given our player some invincibility frames after re-entering the movement state. So that is just making the mechanics feel a lot better for this prototype. So I think that's where we'll wrap it up for this video.